Good afternoon, colleagues. Today, we will continue with the 12 sessions of this special series of webinars on mainstreaming for industrial revolution that is being organized by the Directorate of Digitalization, Technology and Agribusiness. I will start by sharing my screen to introduce the session. Well, today, as I mentioned, we will continue embarking us in a more in-depth examination journey on the 4 IR technologies, their operation, mechanism, and the relevance in the context of a specific set of industrial sectors. My name is Alejandro Rivera Rojas. I am the UNIDO DTA's Directorate Executive Officer, and I will be moderating this 12th session of the webinar series titled Smart Factory, the Future of Production in the Garment Industry. For this occasion, we have invited the following panelists. We have Mr. Bernardo Calzadilla Sarmiento, Managing Director of the Directorate of Digitalization, Technology and Agribusiness. Dr. Calzadilla has been Director for the Technical Assistance and Training at the International Organization for Standardization. As Managing Director of DTA and Director of the Department of Technology, Digitalization and Innovation, Dr. Calzadilla has been leading the work on quality and standards for trade facilitation, investment, for sustainable development and innovation in the context of the 4th Industrial Revolution. With more than 25 years of international experience in global development, his involvement includes working in Africa, Asia, and Latin America. We will have also Ms. Nicolina Pras. She is the director of the ITA Academy and the Digital Capability Center in Aachen, Germany. Ms. Pras did her Bachelor of Science in Textile and Clothing Management and later her Master in Business Administration. She designed the concept for the Digital Capability Center in Aachen in her master thesis. Before setting up the center and the company, she worked at the Institute for Textile Technology at the RWTH Aachen University in Germany and as a production coordinator at Marc Jacobs International in New York. We will have with us also Mr. Xue Xuan, co-founder and CEO of Yelin Textile Technology. Dr. Xuan is a former co-founder of Alibaba Rhino Manufacturing in Garment Smart Factory and the co-founder of and CEO of Yelin Technology in Fabric Smart Factory System. Dr. Chen holds a PhD in Material Science and Engineering and has research experience as visiting scholar across renowned universities, including the University of California. We will be having also Mr. Joseph A. Diffeo, Chairman and Executive Director of URAN. Dr. Diffeo is recognized as one of the world leaders, experts in transformational change and breakthrough quality management. For 33 years, Dr. Diffeo has worked as advisor in the areas of enterprise quality management, Lean, and Six Sigma. Dr. Diffeo has authored several publications, including URAN's Quality Handbook and the Compliant Guide to Performance Excellence. Last but not least, our colleague, Mr. Ricardo Savigliano, Chief of Agribusiness and Skill Development Division in UNIDO, will be also with us. Dr. Savigliano serves also as a focal point for UNIDO, contributing to several environmental conventions and mechanisms, including the United Nations Convention to Combat Desertification, Adaptation Fund, and Green Climate Fund. In his previous position as project manager, Ricardo implemented a large portfolio on environmental protection under several global mechanisms and multilateral donors, mainly Global Environmental Facility, Montreal Protocol, and the Climate and Clean Air Coalition. Dear colleagues, smart factories and smart manufacturing are accelerating the garment and textile transformation from labor-intensive into capital-intensive industries. Besides stitching, cutting, and dyeing, robots can now produce complete garments autonomously. at minimal cost and with high accuracy. As greater levels of automation, digitalization, self-optimization, and interconnectivity continue gaining ground on the sector, reshoring of production back to advanced economy could also increase. This session will explore the challenges, implications, and the role of skill developments, particularly quality and standards, in the transition to smart manufacturing. Our Managing Director, Mr. Bernardo Calzadilla Sarmiento, will start today's webinar with the welcome remarks. Our external invited panelists will provide further insights on the context, trends, potential challenges, and opportunities of smart manufacturing in the garment and textile industries, while our colleague Ricardo will give insights on the work that UNIDO is doing to support skill developments. We will have a round of initial presentations as usual from the panelists, and later we will continue with the discussion panel. We would like to encourage you to raise all your questions using the question and answer box in the bottom of your screen. For your information, we will be also recording this webinar, and we will make it available through our Knowledge Hub. Having said that, I would like to wish the best for all the panelists, and the floor is yours, Bernardo.
Thank you. Thank you. Good afternoon. Thank you, Alejandro, and welcome to all the attendees to this 12th session of 12 already, UNIDO's ISID webinars series. Smart factories is a very important topic. Cyber physical processes have been at the core of the fourth industrial revolution, but it has unfolded so far, and it was a key concept behind the German strategy for Industry 4.0 that was unveiled since 2011 at the Hannover Messe. The very concept of smart factory seeks to utilize data machine-to-machine processes to increase industrial efficiency, to improve resource efficiency, and to reduce the toll on the environment, and to enhance industrial efficiency. This integrated production can also, and this is very important, contribute to pursue a circular economy in industrial production. Also linking it to the pandemic has also been, COVID-19 has been a very strong accelerator of digitalization, and firms seek to reduce their exposure to long-term disruptions in international value chain. We can certainly see that the shift towards digital manufacturing, which has already taken place prior to the pandemic, has accelerated. In these times, we have seen significant disruption. In 2020, global manufacturing declined 4.1%, and foreign direct investment declined 42%, according to UNCTAD. It had serious implications for LDCs, for middle-income countries, and for all those countries specializing in labor-intensive or intermediate goods. Smart factories may accelerate the process of reshoring to high-income countries. It is therefore very important to have a strategic and long-term framework for the fourth industrial revolution to assist the countries in their transition to digital manufacturing and boosting capacities in terms of policies, knowledge, training, skills. For instance, the Oxford University estimated that 47% of jobs may be vulnerable to automation in the future. We know that labor-intensive sectors focusing on repetitive tasks such as administration, retail, and creative industries are especially prone to automation. This may also have implications for the achievement of gender equality, given that women make up majority of the workforce in these sectors. For instance, we have seen in Bangladesh that greater robotization in the garment industry has led to displacement of some female workers, and some, we mean many. Tasks such as pocket stitching and the placement of belt loops were in the first one to be automated, but now advances in robotics are enabling to produce even t-shirts with little human intervention. Likewise, take up of industrial robots is also likely to see a decreased participation in global value chain, being replaced by greater customization, intra-regional trade, localized production, and shorter value chains. In these circumstances, it will be vital to train and upskill young people in order to meet the demands of the future labor market. UNIDO aims to meet this need through harnessing especially the learning and knowledge development facility known as LKDF, which delivers specialized virtual training to young people in developing countries. Let me finalize by saying that we look forward to hear from our panelists. Thank you very much for being available for this discussion, and we look forward also to further cooperation to address this global challenge together. Thank you very much. Back to you, Alejandro.
Thank you very much, Bernardo. We will start with the first panelist, Ms. Nicolina. The floor is yours.
All right, thank you very much. So hello, everybody. It's a pleasure for me today. So I will shortly explain something to you regarding smart manufacturing for the textile industry by using model factories for training and qualification. And therefore, I will share my screen. All right, so let's start with the challenges. So one of the biggest challenges for the digital transformation in the textile industry is, of course, the investment in the system architecture. So if you want to change something, you want to have new equipment, you want to have a digitally networked factory, for example, you have to invest. But today we will have to focus much more on the employee qualification, and because the employee qualification is very important by handling the transformation and by transferring the knowledge to the workers so that everybody knows what is Industry 4.0. Because when we are asking a lot of companies what is Industry 4.0, mainly the companies didn't even know. Some companies say big data. For some companies, the implementation of ERP systems is Industry 4.0, but that's not. So regarding the potentials of the digital transformation, there are a lot of benefits. So I will just have a focus, for example, on the 10 to 30% reduction in maintenance costs when you are using, for example, augmented reality systems by doing some maintenance, and the worker will be instructed to do the right maintenance task. Or the reduction of quality costs by 10 to 20%. So I will have an example today by increase the quality of textiles, for example, with artificial intelligence, or the reduction of machine downtime. So by using real-time data to know what is happening in the factory, what is happening in my processes, to have the full transparency at the end, to make decisions or to make it easier for the operators in the factory to make the right decisions. And we have to train the people nowadays, not only in Europe, in the US, as well as in Asia. And therefore, we founded the Digital Capability Center here in Aachen. And it's a model factory 4.0 for the digital transformation, especially networked to the textile industry. So let me start a virtual tour shortly, just to get a first impression about how it looks like. So this is the center, and you will see a textile production line running. Of course, we have only one machine for each process, but we are starting on the bobbin creel, have in the next session the warping machine with the condition monitoring system with an RFID login for the operators. So for example, that the operators can only see the real-time values that are important for their task based on their operator's level. We have a weaving machine because we are producing a smart wristband with an RFID chip. So everything is completely fully networked. We have a thermosetting and coating machine for making the textile ready for the digital printing process. We are producing lot size 1 here, and have an automatic cutting system. Therefore, on these two stations, we are using a lot of artificial intelligence for the quality optimization or a better energy consumption. And at our last station, we have the assembly line where we are teaching the operators to use different digital technologies, for example, digital assistant systems, especially when you are producing or configuring smaller lot sizes in the garment industry. So in general, we implemented and we developed not only alone, also with some technology partners, and tech players, we developed more than 40 digital solutions for the textile industry. And I will give you an explanation of two examples later. So let me stop the virtual tour and go back to the presentation. So regarding the solutions, as I mentioned before, we are bundling all our solutions in an end-to-end process line. So starting from the sales, so we will get the first information about what kind of product should be produced. And then we have the product development, supply chain management, procurement and material. And one of the main parts is the manufacturing area. By having some different applications or different technologies like digital assistance systems, we are using robotic technologies, for example, cobots. We have an auto-store logistics system. We are using augmented and virtual reality, for example, for the planning of the shop floor and so on. So there's a lot to do, especially for the textile industry, which is a very traditional industry. And we are trying, or we are starting with the first development and teaching and qualifying the operators from the textile companies to use these systems, because these are not any systems which are ready in the next 5 to 10 years. These are mainly state-of-the-art technologies, and everybody can use it, and it's not very, very expensive to use it. But I think we have a lack in the knowledge in the companies that all these solutions already exist and can be used. And back to the definition of what is Industry 4.0, it's not about to use an ERP system and MES systems and collecting all the data. So regarding the definition of Industry 4.0, it's the use of cyber physical systems, which are real systems, such as a production machine or an industrial robot, which have an intelligence and communicate and cooperate with each other via the internet. And for example, this is an intelligent sensor, which is mainly the basis for the digital transformation. So with these kinds of intelligent sensors, we are recording measured variables along all the textile processes. We have a signal processing, and of course, we have the internet connectivity. And especially in the developing countries, internet connectivity could be one of the first problems to deploy some of these solutions. So what is the basis? The basis is normally the condition monitoring. So to get all the real-time data, the relevant process parameter in a textile processes. So we are using normally textile machines. Nobody has to use new machines, because with the retrofitting aspect, everybody is able to make old machines ready for Industry 4.0. And we have an PLC, normally an S7 PLC in most of the textile machines. And then we want to have much more data. So I think there are a lot of data existing in every company, in every factory, but the real challenge is how to generate the benefits out of these data. So that means when I want to have some more information about my yarn tension, for example, then I have to add some more yarn tension sensors as an external PLC on my machines. So that means in the textile area, every textile machine is speaking a different language. So even if you have machines, for example, from the company Dornier or from the company Trutschler, you will have a problem because every machine has a different PLC. And to have one network production where you can use or connecting all the machines together, there are the possibilities to use a middleware, which is transferring the different languages of the machines. So to make the data and the information in real time visible in your back and front end at the end, so that the operator will get the decisions how to react. And yes, so there are a lot of opportunities. So my time is coming to an end. But just as a first impression about what we can do, here's one example of using artificial intelligence for having a lower consumption of energy by implementing or making a retrofitting of a big textile, for example, finishing machines with basic controls and programming some algorithms. So at the end that you have the best parameters and the best quality of the fabric with the lowest minimum or with the minimum energy consumption. So I think there is no time for the last example. So therefore, thank you very much, and I will hand over to the next speaker.
Thank you very much, Nicolina. I think we all enjoyed a lot this virtual tour, yeah, of the Digital Capability Center. Thank you for enlightening us on the potential of digital transformation, and particularly the definition of the Industry 4.0 regarding the context of the textile industry. We will continue quickly with our second panelist, Mr. Shuai. The floor is yours.
Okay. Thanks for Joda's introduction, and I will turn to my slides. Sorry. Okay, thanks for UNIDO's invitation, and it's my great honor to have a chance to introduce what we have done in Yilin Textile in China about smart manufacture 5.0. Okay. I want to start my presentation with definition and target of our manufacture 5.0. We see manufacture 5.0 is a smart factory network instead of one model factory or one prototype factory or workshop. The network will connect the upstream, also downstream smart factories relies on the ABC compatibility. When we say ABC, I mean AI, also big data, blockchain, and cloud computing. These kind of technologies. We build our smart factories network to enable the on-demand fashion production, improve the profitability, and also reduce the inventory levels. Will still be able to meet the personalization needs, also or maybe small batch production. Okay, briefly, we have realized the digitalization of fabrics, also the optimization of production process, and also the centralized capacity, as well as we can scheduling with the production data, build a cross-factory industry alliance, and we do have a significant production efficiency improvement. It's delighted to see that the rate of the capacity utilization increased by 30% in our proto smart factory, and the profit increased by 20%. Delivery cycle, and the pollutant discharge are 50% and 8% shorter than industry average. Okay, so I also want to introduce a little bit of the background of our project. In China, you know, in 2019, the total sales of China textile industry exceeded 7 trillion RMB, where the production capacity and is exceeding like 10 trillion RMB. That means the low resource utilization and supplies production capacity ratio exceeding 30%. So in addition to that, most textile factories basically do not have any R&D compatibility, and the products and the service are highly similar, so causing intense competition and a low profit level. So now most common garment and fabric factories using both make to stock and also make to order ways. For common fabrics, garment factories purchase fabrics on spot to meet demand, which with numerous links in the industry chain, disperse supplier, low gross profit level, high capital pressure for the fabric factories, and the frequent but this kind of frequent stock generation. In another way, when the order is big and not tight deliver, fabrics target to meet the requirements of the brand is usually ordered by purchase order through a garment factory, and then produced by fabric factories that purchase raw materials, also organize the factory production. For this type of fabrics, the delivery cycle is lengthy and the fabric factories need to put in large amounts of funds upfront, and it's also difficult to organize production. What's worse, when the small batch order requires a rapid response and the delivery, this kind of make-to-order will be nothing to do if they do not have any smart capacity. And for this situation getting worse, especially in garment and fabric production process, comparing with the full textile supply chain, because the garment and the fabric is much more non-standard compared with the gauge or yarn or fiber or filaments. So we figure out the solution from both productivity forces and also on the production relationship sides. We provide orders dispatch and the optimal production solution to partner factories based on professional expertise data and the technical compatibilities to improve their production efficiency and stability. Also, R&D compatibility helps extend the business towards the upstream, forming a closed loop of textile industry chain like R&D production and also sales. And then we will upgrade this kind of one smart factory to smart factory network by standardized data, centralized procurement, efficient allocation, and order dispatching intelligent. The core ability and the resource is the industry data flow. We build a platform for receiving all small batch orders, no matter they are in wide product range or require a short delivery time. By using machine learning and modeling, we enable the smart order division. We carry out centralized procurement and also let the cross-factory collaboration based on the one rule, just one simple rule. That means we make each equipment can dedicate to one product, which maximizes the production efficiency. So just like the KFC's factory operation, yeah. So the results are, I think, is very encouraging because just like I have shown in these slides, we use a smart factory system. We help factories reducing the order fluctuations, I think, between the high and the low season. We promoting the annual capacity utilization rate, optimizing the profit level, improving the production efficiency, and reducing the delivery cycle and the pollutant discharge. And we believe we can eventually realize the optimization and the upgrading of the whole industry chain. Okay, I also want to show you some picture of our smart dye factory. It was located at Shandong province, China, and all manufacture process driven by data. Even the design process, we using the simulation design, and we use the robot to handle the fabric when we transfer the red data of both fabrics and machines. We let the robot zoom the fabrics in the heat setting machine with no ether. We also use AGV to transport fabrics from warehouse to workshop automatically. The dyeing process is automatic, including automatic switch. After the fabric is taken out of the dye machine by robot, it is automatically squeezed. We also developed a dye transport system and the intelligent color matching. I think it should be said color matching system. All this process was driven by data, and all this data process can be monitored in the data control center. At the end, let me show some more videos about our automatic trial. The first one is a dye matching and a dispatching process. Okay. The second video is the process of the automatic squeezing when the fabric was after dyeing. And the third one and the fourth video are about using the robot handle the fabric in the front and the end of the heat setting machine. The third one also exhibits the automatic sewing and the cutting process. Then they will do some automatic sewing and then cutting it. Yeah, okay. That's just some video of our factory. Yes, that's all for my presentation, and thanks for your attention. I'd like to express my gratitude to UNIDO again. Thanks for your invitation and organization. Okay, I will
Thank you
continue.
very much. Thank you very much, Dr. Chan, for sharing all these very nice videos on the factories, and for sharing with us the definition of the smart factories network that you have developed, and particularly how these type of technologies like artificial intelligence, cloud computing, and big data combined can help to overcome the problems that the textile industry may face in the current context. Thank you very much. We will continue now with the third panelist, Mr. Joseph. The floor is yours.
Thank you very much. Trying to keep the time limits and trying to keep everybody entertained is often more difficult than it seems. Thank you for the education on the garment industry. As a non-garment expert, my expertise is in quality management and international standards related to that. But we have been over the last 5 years working to transition our own industry, and that will impact your industry. And so my short presentation here is kind of get you up to speed on what's happening there. The garment industry itself, as compared to other industries such as microelectronics, chemical processing, pharmaceuticals, missile defense, historically has not been at a very mature level when it comes to quality management practice and even technology practice. A lot of the technology in the supply chain, even from the presentations, has all been in the production of raw materials, the cutting, dyeing of various textiles. When you get into the assembly of clothing, there's still quite a bit of room to grow. And so when we think about quality standards in a smart factory, there's varying degrees of that need, from very high tech to very low tech, from very machine capable, machine independent of people, to very labor intensive. So the role of quality within those.
Sorry, Joe, we cannot see your presentation. Yeah, just in case you want to check.
So looking, thinking about your total value chain, a lot of the work in the front end, planning, design, sales, order, understanding customer behaviors, that's pretty high tech. The further you get down into production of assembly of clothing, it becomes less high tech, and that's where a lot of the problems happen, and also where a lot of the technology has yet to go, and will get there, because some of the things you just showed are pretty impressive. I'm not going to talk about a smart factory, but what is the role of quality and standards in that? We see it's going to be changing itself, because quality management is changing to become smarter. But I think the role of standards in helping to improve interconnectivity is probably going to take more and more shape. I know the technical committees related to quality management are addressing digital quality concerns, because the more you remove humans, the greater confidence you have to have in the system you have. So I think there's going to be more and more standards around that. If we think about the value chain as being a whole bunch of intelligent machines with all this capability of advanced analytics, and all those people that are working within that, what's keeping them all on track to produce something that's efficient and effective? And those are your standards, and standards related to electronic capabilities, as well as the quality standards, the international standards for how to incorporate quality into design, then maintain it in control, and then continuously improve on it. And that quality and standards piece is transforming itself right now. And the driver behind all quality standards changes are the ability of those sensor technology to take the information from the machines and put it into controlling the process so that you don't get 10%, 15% less yield. You get 99.9 yield. In other words, the sensor technology, which allows you to get information about the performance of the equipment, is also the same technology that's going to maintain the performance of the equipment. And we're seeing tremendous amounts of reduction in defect rates because of that. Also, the speed at which quality management happens is much better today in a smart factory than it was. Think about it. If we have to collect data, interpret that data, actually manipulate it, interpret it, and then react to it, hours, days, and weeks go by. So if we can create real-time data, the speed at which we do that is obviously much quicker. Now, where in an organization are you seeing the use of the technology? Well, clearly in the voice of the customer and monitoring behaviors. I assume that Nicolina mentioned that she was with Mark Jacob, but the brand companies and the companies that are monitoring behaviors are getting much better information on what people want. That's led to such places like design your own clothing for your own size, for your own fit. So clearly the intelligence in front with the information they're gathering. The inspection, as you just noted from Shuai's presentation too, the inspection is becoming more sensor driven. So you're getting better uniformity of yarn and textiles. And that will continue. And that, of all the quality management activities going on, the inspection tools have had the most experience over many decades, and they're getting better. Machine maintenance. Many organizations wait too long before they have to maintain a piece of equipment. So by monitoring real time with new technology, you could predict when the machine needs to be maintained, just like our automobiles are now, where they constantly send us warning signs. Audits. The difference between an inspection and an audit is frequency. And so we have many audits in organizations because we have many defects and therefore a lot of inspection. Well, as inspection gets driven down, audits will be getting driven down because confidence will build and capability will build. All kinds of material testing going on during and after are getting easier and closer to where the operation is happening. Even root cause analysis and corrective action is benefiting from artificial intelligence. We see a lot of querying programs that are able to query data to see patterns in the data that we may not see ourselves, or because we have to extract that data, put it into control charts to see it. And so root cause analysis is getting faster. And then, of course, the work instructions, the ability to train someone quickly on the job is getting easier and easier to perform that job with real-time screens, real-time television, real-time monitoring, and real-time education, which provides work instructions. Now, all that said, managing the quality system was a paper-driven activity. And now it's going to be a real-time data-driven activity through the technology. So changing work instructions, changing training, reducing sample sizes is going to happen instantly. What does that lead to? It leads to visual work instructions, better training, faster audit, better machine monitoring, better tracking of jobs and visibility. And through all these different applications, leads us to a really change in how we think about the cost of quality. We think about the organization as one that spends money and gets a profit. But part of that money they spend is additional money to assure the quality meets our requirements. Now, if everything worked perfectly in our operation, we wouldn't need that, but things don't work perfectly. And when we examine that cost of quality a little deeper, we can divide it up into categories. The failures, which are the bad quality, and the prevention, which is the good quality. And the appraisal is a little bit of each. After technology is introduced, historically, we've been affecting the failures. Let's drive down the cost of failures. But what's happening is we're driving actually the cost of quality down. The cost of prevention is cheaper. The cost of appraisal is cheaper. And then, of course, the more you do of that, the less failures you have. So what's happening is we're actually getting more profit from the existing resources and reducing all that activity. And unfortunately, a lot of the activity is still been a lot of human labor. And so that is going to reduce itself even more. So with that, the cost of quality and the cost of poor quality as part of that are going down, therefore making us more profitable. And we see the same kind of numbers that was shown there, 10 to 15% reductions in cost of poor quality, which is mostly occurring in the prevention costs, which have been ignored for a long time. So that's my story, and I look forward to continuing and getting into the panel. Thank you.
Thank you very much, Joy, for this very comprehensive introduction on what could be the role of quality and standards into the transition towards smart manufacturing, particularly for bringing us on the challenges and the opportunities of these new technologies could bring to the quality management. Thank you very much. We will continue now with the last panelist. Ricardo, the floor is yours.
Thank you, Alejandro and colleagues. I have to say something while I'm waiting for sharing my screen. I have to give you let's say a comment. I mean, usually among colleagues we have to help each other, right? But putting me after this panel, it's not helping at all. I really like the journey so far, and let me try to also be, let's say, constructive as well, no? In this webinar. I'm aware that the time is running out, so I will try to be very brief. So another point, I was criticized that my presentation didn't have let's say an opening slide, but actually I wanted to start not with a title, but with a message. That is what the industry is facing, the industry at large, not only the textile and garment, let's say, industries, but this is what in all the, let's say, around the globe, industry is facing. So it's a huge issue related to the mismatch between the skills demand and then in the skills available on the job on the market. So that is affecting particularly and primarily women, and there is also a very strong link with the climate changes, migrations, movement of people, in particular related to climate changes. Many organizations around the globe are trying to understand the impact of the COVID on that mismatch. Bernardo at the beginning said that actually the COVID is accelerating digitalization. That's something that may also increase further this number. So the digital gap may also is expected. I mean, we are studying. We are also with other UN agencies trying to, many research institutes. We are trying to monitor actually how the COVID is impacting that already huge deficit now of the industry. Going into different industries, of course, the magnitude of that is different because different industries are requiring different skills. And now here we try to put together a couple of examples of two industries which are kind of product-based, but of course with differentiation, the textile and the machinery at large. And the categories are very big. I don't want to enter into the methodology, how to come with those numbers. I mean, they are taking, what is I would like to highlight, those numbers are more and more coming from LinkedIn and those, let's say, web platforms where industries are looking for future workers. And basically that assessment is based on the requirements from industries at the time of hiring people. So we see many similarities between textile and machineries, but when we go and then on the column on your right, on digital skills, you see that there is a big difference. The digital literacy is always there, and we saw that product-based, let's say, industries are in any case keeping that requirements in their market search. But the graphic design and the social media for the textile industry is extremely high compared to other sectors. And then that goes into as a contribution, no? Additional to what colleagues said before, helping the industry to understand the market demands and also try to place on the market products which are matching the customer requirements. It's also interesting to see, in particular, textile industry, how those skills again were changing in the past years. Again, what is here not available is 2020. We are expecting the data to be available mid-2021, and it will be interesting to see. We are definitely all expecting the digital skills to get a very high raise in the graph, but still we can see already that digital skills are already in the textile industry more, let's say, important from the hiring industries than specialized industrial skills. That is also a very good piece of elements. It's a good piece of element, in particular when it comes to design education programs and programs for knowledge development. And then comes our, let's say, our solution or our approach is that is what is basically proposed under the LKDF, and is an acronym which stands for Learning and Knowledge Development Facility. So it's a kind of a global platform where industries are sharing their knowledge, and future workers or workers can get, let's say, additional information to upskill themselves. And of course, that platform is also helping governments and decision makers to try to refine their education programs, but again, always based on a industrial demand basis. What the LKDF does, which is also very interesting from our perspective, is that we put a lot of emphasis on the monitoring of impacts of education programs, and that is also something that is helping us directing investments into the education system. So at large, methodology works on what we call PPP approach. We added the D, which stands for development, because it's not only a private public partnership like as defined by the World Bank, where the public sector is getting basically an asset from the private sector. The private sector is handling an asset owned by the public sector and then gets profit out of that. No, here basically the asset is shared, and by sharing that asset between the public and the private, risks are shared, and the sustainability is actually increased. So we are fostering in all our interventions a very, let's say, dynamic and active participation of an interaction between the private and public sector, and that is what is making our LKDF kind of special in many educational programs. We are mainly present in Africa and Arab countries, but we do also have operations in Latin America and in Asia. And actually, in Asia, we are currently expanding our portfolio. Some few success stories. We have examples, and maybe we can share some links, Alejandro, later on to participants, where we can, people can also navigate in our website and get the different, let's say, projects where we are currently working, or we worked in the past. Those results are usually measured after months after the program is ended. And then let me get back to what I was saying before. So we pay a lot of attention into the monitoring of our impacts, but long-term monitoring. How the future looks like, we think that that it will be more and more, let's say, going into what we call MSD approach. So a market system development approach is an approach where basically the solutions are looked into the markets, and basically all project interventions are aiming at transforming the market framework, and so that to bring long-term impacts. It's a methodology very scientific, so very well detailed. I mean, that's an information for colleagues in UNIDO. We know that also in other departments, I mean, this methodology is being implemented and is extremely powerful, and that LKDF we are using it quite successfully, in particular again into the education system. So, and with that I conclude, and I hope I contributed as expected. Alejandro, the floor is yours.
Thank you, Ricardo, for bringing us on these insights on the relevance of skill developments in the context of the textile industry, and particularly looking into the future. Yeah, and also for the overall explanation on the LKDF UNIDO platform, that for us is a very strategic one, particularly for implementing the 4th Industrial Revolution strategy of UNIDO. There is a major role for that one. Thank you very much. We will continue now with the questions. Yeah, the first question will be for Nicolina. Nicolina, as the automation and digitalization levels advance in the garment industry, the demand for human labor also decrease. In this context, what is the role of training and skills developments, as our colleague Ricardo were more or less mentioning, and how can developing countries better prepare for this transition?
Yes, so first, I wouldn't say that there is a big reduction in personnel, because it is very difficult to automate in the garment industry, especially at the end of the supply chain, when we have the sewing and the assembly part. So textiles are very flexible materials that can be very damaged easily by robotic systems. So therefore, just as an example, there are a lot of robotic systems existing, for example, by changing the bobbins on the bobbin creel or by sewing only straight lines. But as soon as you have many different layers, for example, and very complex garments like sheet equipment, for example, it's very, very difficult to use robotic systems. And we are doing a lot of research and development in this area. So therefore, we don't have a look on reducing the jobs in our case, but we have to look on how we are qualifying the people by using the new systems. And especially younger people are not learning anything about Industry 4.0 or digital transformation in school or in universities. Nobody of my team or nobody of all the people that are dealing with the topics has learned something about that in school. So I think that is the first problem. So there are very good opportunities today for getting some free learning sessions online based to get a first insight about what does it mean to implement such technologies. And of course, Industry 4.0 is a very, very big topic. So we have a lot of different technologies, but we have to qualify the people to work with these technologies instead of replacing them. So yeah, that's my opinion to that.
Okay, thank you very much for sharing your opinion with us on this. The next question, we will continue with Shuai. Shuai, what are the critical challenges companies face in developing countries to close the gap between traditional production methods and smart manufacturing? And how could these challenges be addressed?
Okay, thanks. And I think that's a good question. Actually, smart factory, that smart manufacturing can be realized by 3 steps. And they are, the fourth step should be automation. The second step is digitalization. And the third step and the final step is a smart manufacturing. So that means industry big data from the digitalization process is is a key point for the smart manufacturing. Then we can see maybe some developed countries will follow the sequence of automation, digitalization, smart manufacturing based on their economic strength. So they usually begin with lots of investment on the most advanced automation equipments. Then they will collect the data with high efficiency from these new machines and softwares, and finally realize the data-driven smart manufacturing. Well, for the developing countries, in my point of view, I think they can choose another path by firstly collecting industry data, maybe by hand, but it's also okay. And also at the same time build the industry data standard. Then they can do some investment on equipment step by step. And even they could start with not most advanced models. Okay, then we can use this data to driving the factory to produce some how to say standard or normal product at first based on because our labor cost advantage. And you know, and this kind of normal products is not the priority of the developed countries. So after the data and the profits is full collected, then we can upgrade the manufacturing factory to the smart network, or we say smart manufacturing. And it seems like some new global division, and I think it could be organized by UNIDO. It's kind of my point of view.
Okay.
Okay.
Okay, thank you very much. We take note on that one. The next question will be with Joy. Joy, a smart factory's operation requires protocols for ensuring connectivity among devices, ensuring the secure data transition and interoperability with other systems. Within this context, what is the current standards landscape for these systems? Are there current standards fit for purpose?
If you had stopped that question before you said fit for purpose, I would say maybe. But when you added fit for purpose, you know, industry by industry is at different maturities, and the standards tend to be made for one level. So some people are above it, some people below it. I don't believe that the new standards are fit for the purpose going forward in smart technology. For instance, some standards mandate you must do an audit. Why do we have to do an audit if we have perfect control? Some say we must do a sample size of X. Why? So I think the standards have to change from mandating activity to helping us understand what activity we should monitor. And as long as that is in control, life goes on. And so that's one aspect of it. The other aspect is the relationship between supplier and the business. So you have many suppliers of dyes and materials and raw materials. That relationship and that connectivity is very important. And that's when we get into a lot of global supply chain issues. So I think the standard has to definitely improve to get to a level where you can connect easily and better. And if you think about it, just connecting between countries' internets is not as easy business to business. So I think there's going to be a lot more standards changing, and they're not fit for purpose. They haven't been fit for purpose even under the old technology in some cases.
Yes, okay. It was a tricky question, but it's good that you mentioned that. Thank you very much. We will continue with Ricardo. Ricardo, how can we ensure that skill development become a truly inclusive process? What specific measures do micro and small, medium-sized enterprises need to implement in order to reskill or upskill the workforce while driving inclusivity?
Thank you, Alejandro. I think, the question has two components. One is how to make it inclusive, and I think it's by policy, by investing on policy and on infrastructure. Infrastructure should become more inclusive, and in particular the physical infrastructure, the way the programs are offered, the skills development programs are offered, and so on and so forth. But let me say also 2 points here. One is the support from digitalization. As Nicolina was saying, there are many ways of using, let's say, digital platforms for skills development, to boost the skills development, in particular digital skills. We are now developing some projects in partnership with the gaming industry, for instance. That is something very interesting. It's an area where skills development could definitely go and reach vulnerable people and also displaced everywhere. So it's something very interesting concept and very interesting support that the digitalization is bringing us, in that regard. And the second point is how micro and small, medium enterprises could, let's say, promote upskilling and reskilling of their workforces, right? That was the second point. And I think it's always an issue trying to convince MSMEs to invest in skills development. But actually, we have to also support them in a way that the human factor of those SMEs is actually their strength, right? So investing in reskilling and upskilling the workforces for them is investing in their main reason of business, right? So again, it's difficult to reach out to those small companies, sometimes informal, but definitely bringing them together, partnering them together could be also a good way forward. And something that Joy mentioned and also Shuai mentioned before, it was this, let's say, global network of knowledge somehow. Shuai mentioned it in a different way. So he connected, he proposed this connection of companies in the smart way, but we are also aware of examples of businesses run in a similar way. Think about those innovation labs or fab labs, where basically the knowledge is shared across the globe, and basically businesses are looking into shorter value chains, taking advantage of the knowledge coming from those global networks, these global networks. How to help those SMEs entering those networks, that's probably a job for governments, and then maybe for implementing agencies like UNIDO and partners we are working with. But of course, going back to LKDF and the role of the partnership of the private sector, I'm here inviting colleagues here, other panel members, to please approach us, approach LKDF, because you may be really helpful to share your knowledge within our network. And that's I did some internal advertisements.
Thank you, Ricardo. Thank you very much. We will change a little bit now the questions. Yeah, sorry, colleagues, it's Friday, so we want you to be more awake and also more active. So, Nicolina, I will change a little bit the questions that we initially discussed, and I will have a new one for you from the floor. Yeah, we think, and of course, if you don't feel comfortable with that one, we can pass it to another panelist, but I think you will manage. Well, the question, in fact, is related to the accessibility of this type of technologies when we are considering Industry 4.0, yeah, particularly for enterprises in developing countries, in terms of cost and logistics, and particularly also considering in many developing countries, labor cost is cheaper. And this is basically the advantage that they foresee in many aspects. So what can you tell us on how to make more accessible this type of technologies for SMEs, for private sector in developing countries? I give you the floor.
All right. Thank you. Yeah, so it's a very difficult question because every time when people are asking how much benefits will I have by adding these technologies, what do I have to invest? This is very, very difficult because every solution is based on the existing equipment, for example. So I think to mention some numbers, we have to know how the processes are going on, what kind of machineries is existing, how does the IT infrastructure looks like. But regarding the accessibility, so there are some good opportunities, I think, on the market. So there are, especially from the European Union, there are public funded projects for bringing the digital transformation forward, especially in developing countries. So I think there are some big projects in Ethiopia running, as well as in Turkey, which is not a development country, but this shows, for example, that there is a public funded project running where more than 100 textile SMEs are digitally transformed in cooperation with European companies. And I think these are very fruitful cooperations. So I think it makes sense to check regularly what kind of public funding projects are existing and how these developing countries and SMEs can cooperate with European companies or from the US, just to have a big consortium, and by doing this together and learning from each other. And I think there are quite good opportunities, but it's difficult to find them right now, to be honest.
Okay. Thank you. Thank you very much for accepting the challenge. Yeah, I will continue with Shuai. Shuai, I will do the same with you. I will take one question from the floor. So let's forget about the one that we agreed before. Yeah. So for this one, yeah, what I get from the floor is regarding the input data, yeah, for an integrated smart factory, like the concept that you define it and show it to us. Is managed centrally or is section-wise? For example, considering spinning, weaving, finishing, and garment. I mean, all the different steps involved in the process. Yeah, and how to balance each process. How is this managed in a new technology? Do you understand? It's talking more on how to apply, I mean, how these technologies that you are using for improving the efficiency and the capacities used in the industry, how they are managed. They are centrally managed, or they are individually managed according to the different processes that you were mentioning?
Yeah, okay. Just like what I have said, because for the yarn and for the fiber, for the filaments, and also for the grid, maybe for the grid, it's like something like a standard product. So for their process, I think they can to do some to made to stock, and it's something like more safe than that what we have. If we do some, it might be more safe than the dyeing and the garment factory. So because they are non-standard, so that means if we can pay more profit to this kind of young and fiber factories, so they can just to do some stock storage and to make the whole process can to like something made to demand. I think that's a good way and a better way to keep the balance, because just like the fabric process and the garment process is more close to the brand and to the customer, and it's always changed. So they really got more risks than this kind of how to say than the young and process, something like that.
Okay, thank you for accepting the challenge as well. Yeah, I will continue now with Joy. Joy, in your case, you are safe because you already answered the question in the chat. Yeah, so I will still keep the saying that we agree. Yeah, Joy, during your presentation, you explained how smart factories are impacting the overall cost of quality. In this regard, what are the implications for enterprises with less automated and interconnected production systems? How could they be better prepared?
So that's the state of many industries and many organizations. So don't feel that garment industry is any different there. Everybody is trying to figure out how to prepare for the future. But I'll give you an example of how I think about it and how we think about it. A number of years ago, technology started to really change the way automotive production was happening. And if you didn't fix the business process that fed this automated robotic production process, you sped up production and you got defects faster. So if you don't attack the process prior to technological, you're going to get defects faster. So technology isn't just about faster, it's about actually replacing elements of your system that will make you more efficient, which yes, will make you faster, but also more effective. So for instance, we need to think about quality before your technological change. Why do we sample? Why do we sample? Why do we do tests every hour? If we just put those into a new technology, we're not going to gain from the technology. The goal is to think about eliminating those steps and what has to be done to eliminate those steps. So the technological changes of making sure you have proper setup control, proper controls of the equipment that are producing it, the driver downstream of it, you don't have to do those things. And that's the benefit. Someone asked about the robotics, which is related to this. Robots aren't going to be collecting samples and testing. There's just going to be less things to test. And they'll be testing early on rather than later. So it's not that robots are going to go around picking up samples. The robots are maybe helping us move material. The robots may be doing some sewing or things like that, but it's not going to be pulling samples for you. That's not a job that should be done.
Okay. Thank you very much also for answering that one as well. Yeah, I will go with the last question. Ricardo, considering the garment industry current automation and digitalization trends and the increasing potential of reshoring of production, what can micro and small and medium-sized enterprises in developing countries do to support a systematic development of digital skills among their workforces?
Thank you, Alejandro. I would probably revert the question to us. No, what can we do for SMEs, MSMEs in the garment industry? No, and I think it's what we could do is to try to, let's say, promote an ecosystem for innovation, something like that. where digitalization definitely is going to play a key role. And that is the kind of innovation ecosystem that is what we could offer, no, to those MSMEs for their development, no? And definitely within that innovation, a large part should go into the kind of design approach, product design, but also process design, process improvement, product diversification. But also what he was also saying, Joe, all those automation could lead to a more transparent process, right? Could help those MSMEs to reach out to markets with an easier way, and also last but not least, ensure that principle of circularity are integrated and measured in the process. So that's I think is I would not expect the MSMEs to do all that. It should be, I think, I mean, some support from our end.
From our side, thank you. Okay, very good. Thank you very much. I would like to thank again Nicolina, Shuai, Joe, and Ricardo for sharing with us all this knowledge and the presentations, and for participating and taking an active role in answering all these questions. I would like now to remind to everyone attending this session that we have the recordings available at the Knowledge Hub. I will like also comment that the many questions that we received and were not answered here will be later on be addressed by the panelists, and we will be sending you the responses. If you still have any other queries, you can contact me or my colleagues at the Office of the Managing Director. And I will like to thank you, all of you, for having attending this webinar series. And let's not miss the next one, when we will be talking about how digital technologies can also promote safety and environment sustainability in mining operations, another sector where we are also working, particularly our colleagues from environment. And the invitation will be sent out soon. With that, I'm ready to close the session. I would like to thank you, all of you again, for being here with us today, and we look forward to working with everyone in implementing our digital transformation strategy. Please have a nice afternoon, night, or day, according to the different time frames. Thank you very much, colleagues. Thank you very much.